Hey, everybody. I'm going to get things started in just 1 second. Um, title a little bit of a misnomer. Yes, we are going to talk about vertical slice architecture. This was originally a conference talk. I got to do just once in a weird abbreviated form. Today, I'm going to drill down pretty tightly on Wolverine and Wolverine trickery, but we'll definitely see some Martin and we'll see a little bit of EF Core. If you happen to be any kind of functional programming fan, this might be the great one for you. We're going to show a lot of Wolverine things it does with functional programming. So we get into this a little bit. All right, just set the stage just a little bit. We won't go very long. Just have a quick discussion. What does it actually mean to have good code? What is the best scenario? What are the qualities you really want? Kind of based on recent decade of coming in behind as a consultant, coming in behind a lot of code bases, old enterprisey systems that were problematic to work with. The biggest thing is really how easy is it for us to reason about the code? Can we look at an operation and understand the side effects, the cause and effect? If I call this web, we call this web service, this HTTP endpoint, how many different database queries does it make? Where does it make them? Are we going to introduce bugs if we throw in a little if-then logic somewhere for this special customer? Code that's where it's hard to predict how it works or hard to understand the cause and effect. That's where going to be the most problematic. I'm going to kind of hammer on that idea of not being able to understand your database interactions, because that is the single most common source of very poor performance that I see in the systems I help out with. It's actually the chattiness of the database interaction. I think the long term, the only truly reliable way to get to good results in coding and software development is iteration and adaptation. So it's really important to have technologies or approaches that makes it very easy for you to iterate. It could be as simple as how hard or easy is it to add a new field all the way through the screen? Do we have a wormhole anti-pattern where we got to do 10, 12 different steps? How hard is it to add a new HTTP endpoint or to break message handlers up so that they're doing an atomic action instead of doing too much? If iteration is hard, that's, one, you won't do it, or you end up kind of bloating code, throwing in if-then statements, throwing in new services just to put some conditional stuff into your IOC, things that go bad. We talk about architectural strategy all day long, layering approaches. I think the single best thing you could ever do to make your code base good over time, it's having really effective test automation coverage, your safety net. Theoretically, if you have good test coverage, you're going to be able to make changes. You're going to be able to fix whatever happens to be wrong with your application, or be able to evolve it over time as the business changes or your sales team promises really wacky stuff later, right? Improving performance, that safety net, and that's kind of important here. Modularity, I'm throwing this in here. If you follow me, I'm a little bit dubious on the modular monolith stuff, or not really dubious. I just think there's more complexity than people are admitting right now. One thing that's really valuable, as opposed to some of the clean architecture type approaches we all see out there, is your ability to update or upgrade a system. If you have to upgrade the database or some library across an entire huge flat layer, you're just not going to be able to do it, not very easily. But instead, if it is some kind of modular system, if you can upgrade the database usage or use a new tool on just one module at a time instead of the whole application at one time, you're just more likely to be able to do that. And then lastly, a little bit of a theory of mine, I think is proven out, that if we can purposely choose technologies that are friendly and play nice in integration tests. Here, my thought process, the value judgment is, if I can use a Postgres database, I can spin it up on the fly, I can set it up and tear it down pretty quickly, then running full end-to-end integration tests through the database, not that big a deal. As opposed to trying to throw in a ton of layering and abstractions and deal with a lot of mock objects and tests. Sometimes, not always, once in a while, it turns out to be easier if you can just collapse down to a little bit of procedural code, but test through the database. Sometimes. Hey, Gabriel. That is cool. I grew up in a small town in the middle of nowhere. It's kind of cool that every single day talking to people from different countries, different continents, that never really gets old. So I won't spend too much long on this, but the state of the world today, we're in the middle of a reaction and a backlash to layered architectures like the clean architecture approach. This is 100% a well-intentioned idea about how to maintain, how to control complexity, how to enforce separation of concerns, how to hopefully create a little bit of testability, theoretically giving us the ability to swap out infrastructure later. I think that's bogus, but the theory. I'm sure some of you are using this and it's working out great. I've sure seen it go badly a lot of times. So let's talk about that a little bit. So that's supposed to be a Wolverine and a Martin hanging out at the scene of a crash. So just thinking about how enterprise-y code goes wrong. Maybe it's some of the things I've already talked about. Code, it becomes very hard to understand, where do I go make this change? If I make this change, what's going to happen? Can I predict what the performance implications are of this? If I make a change way over here, why is it going to break something 5 layers down? Or, as I see pretty frequently, our application is very slow. Eventually, the root cause analysis turns out because you're making 150 different calls to a Redis cache in one web request, which is a true story. And I'm going to apologize to the person that told me about that if he's on. I had to stray slide, and I just didn't want to throw it away. Something that had a lot of impact on me when we were pretty early in the Wolverine days, working on some enterprise systems that were using a different messaging framework that allowed you to push in the gateway to messaging very deep in the IOC stack. So you'd be looking at a command, and there are just tons of if-then statements that call through to one service, to a second service, third service, way deep in there. It would be sending messages based on various rules. The killer problem was there was so much distance between the initial input of the system and where all these outgoing messages were, to the point where it became very hard to untangle how the system worked. And when there were production bugs, because there were all the time, what was the root cause? To the point where only one architect who'd been on this way too long could unravel it for you. So best practices for Wolverine, that's why we're trying really hard. We're going to say, keep your call stacks short. Even if you have to call through services from a handler or an endpoint, you want to make it as clear as possible, where are the messages coming from. Ideally, I want all the messages that are sent back out of a handler to do new work. I want that visible somehow in the main handler body so you can see it. And a lot of this is going to be done by just trying to collapse the layers. So just fewer hops to go to find, where did this message go? Who publishes this? So as a reaction to the clean and onion stuff, Jimmy Bogart coined the term vertical slice architecture. Years ago, called it feature folders. I think Jimmy made the name up that name as well. The idea here is get away from those huge layers where everything's divided by technical stereotype, and put code that's very closely related together, right? Pretty easy idea to sell, especially for me. 1 second. can't say, honestly, can't say I've heard pipes and filters come up very often. But when I was just looking at the chat, when I was very young to software development, that was the predominant architecture because I was in a shop that was an ex-COBOL shop. That's basically everything they did was pipes and filters. Kind of looking at one more slide on vertical slice architecture, and I think we're going to get into Wolverine. Things I want to focus on. So the before world, clean onion architecture, hexagonal architecture. We're organizing too much on technical stereotypes. We're putting all the controllers together. We're putting all the repositories together. We're putting all the entities together, even though those things don't have anything to do with each other and they all change at different times. And then everything's kind of scattered around your solution. The analogy I like to make, one of my first jobs, actually my very first official IT job in big IT back in the days of CMMI and Waterfall and all that nonsense. I got kicked up to the architecture team, even though I was in my mid-20s. And they had all of us architects sitting together on the first floor. So I'm sitting with a bunch of COBOL guys. And all the developers and testers that I actually worked with, and even my project managers, were 100 to 200 to 300 yards away in the building, up elevators. And this is before any of us had official instant messenger tools. So you can imagine what a nightmare this was. We actually literally communicated by email or sneakernet. Instead, we want to organize code around business capabilities. Vertical slice, we'll get into that. It's mostly going to be probably some kind of transaction in the system, some kind of input. I think, folks, if you get one and only one thing out of this whole talk, well, please don't hang up after this is over. But we have been too noun-centric in the recent past, the last 10, 15 years. These clean and onion architecture templates, they show, we have an invoice and we have an order in the system. So I have an invoice controller, an invoice repository. Every single thing to do with an invoice is all gathered up in these huge layered bloated classes. Instead, kind of even moving, and this has come along with CQRS, let's be verb-centric instead. Think about the transactions, the operations within the system. So now we're talking in terms of create an invoice, approve an invoice, schedule delivery, the actual inputs and functionality, the tasks within the system. We're going to organize around that instead of trying to group everything in entities. And of course, I just don't like this. I don't like having a million different .NET projects where closely related code is just scattered all over a repository. I definitely think it's easier to discover a system through that idea of screaming architecture, where you can look at the functionality very cleanly of maybe you even have a file called create invoice, and everything related to create invoice is there. Maybe it's a folder. We'll get to that. And of course, the bottom at the end of this, those prescriptive templates, I think that people take off the shelf of, I'm some highfalutin architect writing YouTube content, and here is my clean architecture template you should use. If you hand those kind of prescriptive templates off to developers, the problem is that they will actually follow them, even when they shouldn't. And instead, let's kind of be more adaptive based on a feature's needs. Sometimes that prescriptive template is overkill for very simple things. So let's collapse it down. Sometimes a single feature is way more complicated than the template allows. And that's where you start to see those massively bloated controller methods and service methods and whatnot, because the template doesn't say anything about cutting out helper classes or helper methods. So let's be more adaptive. Mostly vertical slice architecture. The mass majority of resources I think you'll find in the .NET world, almost inevitably going to be talking about the mediator tool or a logical mediator tool, the 10 or 15, probably perfectly fine, just like mediator, but 10% faster tools. An MVC controller or minimal API is dealing with HTTP input. It's calling a mediator it's calling mediator, which looks up a handler, which maybe goes through the whole clean architecture slice. Maybe it doesn't. There's a little bit of asynchronous behavior over here. Just want to kind of point that out. If you're watching this and you're comparing Wolverine to mediator, you could technically use Wolverine as an almost drop-in replacement for mediator, but that's kind of largely wasting its capabilities. And then especially when we get to talking about how does the handler raise events or messages for further processing, Wolverine is integrated with the transactional outbox for resiliency. Mediator is not. I know people use this all the time, the notification handler. I've seen clients use this where they really should have had something more resilient, which Wolverine can be. All right. So I said this was mostly about Wolverine, and we're finally here. Vertical slice architecture the Wolverine way. I think Wolverine's actually got some special sauce here. Wolverine does more than anything else on the server side to reduce code ceremony, to shrink down your code, to allow you to drop and eliminate a lot of layering without necessarily losing out on testability or resiliency or observability. The big goal here is to really shrink your code down so much that it's easy to reason about, it's even easier to test. And surprisingly to me, 5 years ago, Wolverine has largely gotten here by adopting a lot of functional programming kind of thinking and concepts. I mean, a lot of that's come in from the community, but once that ball started rolling, it's made more and more sense. So I won't necessarily say we're an FP tool because I really hate being lectured by F# people. But how about we are at least FP curious or FP adjacent? And for F# folks, we do have F# users, and we have tried to work with our clients to make Wolverine better for F# when things come up. When we're talking about a slice, if we're talking about Wolverine, it almost heavily means to me it's handling a message, which is probably either a command or a query. Also handling an HTTP request, which is kind of the same thing. It's you're either issuing a command that's going to change the system or you're querying for information. There are other things, background processing that may fall into this, or just really logical operations. But for the rest of this talk, a slice is synonymous with whatever code it takes to handle a single message or a single HTTP route. And just to get a little bit of AI slop in here, I want to kind of bring this up, just have this discussion up front. Does the usage of vertical slices almost automatically mean that you're using CQRS? Do these things always go together? You know, obviously you can do CQRS without vertical slices. I think this goes together really well. I think the vertical slice approach just fits a CQRS kind of thinking really well. And I don't think it would be all that useful for pure CRUD systems. So I wouldn't go so far as to say that these two things are locked together, but kind of. All right, quick question. Probably being scared about magic inside of Wolverine. 100% valid concern. I don't know that I have, I didn't really kind of rig up an example for this. One of the things you can do with Wolverine, when we get into handlers, is that Wolverine is generating code around your code, telling you exactly what it does. Here, let's get into things. And I'm going to come right back to that in just a second. I'm going to tell you how Wolverine can unravel and explain the magic to you and what Wolverine does to ameliorate that compared to every other conventional magic tool you've ever used, including some from me. All right. Single, let me check my notes. Let's finally get to code. And that's not the one I want. Okay. Pretty ridiculous. This is from sample application. Let's say that we have a slice where we need to create an item. I don't know what an item is in this world. Let's just go with it. I've got the command message itself. If there's not a reason, if it's not a shared library command, like this is all internal, I like to just put the command and the handler just all together in one place. Some people will even make it be that put the handler as an inner class. I mean, I'm kind of agnostic on that. But let's just talk about some of the things we can do. Right off the bat, it's pretty simplistic. Wolverine has some built-in Fluent validation middleware. Well, it's an add-on library, but pretty built in. That's going to bake just the presence of this and that middleware turned on, assuming this is in the IOC container. Here's our actual handler. And I'm going to show you that it's actually, I want you to notice a couple things here. One, we're not implementing any interfaces, right? If you're used to in Service Bus, Mass Transit, Mediator, any of the similar tools, Brighter, they're what I call iHandler of T frameworks, where there's always some kind of interface that you have to implement to plug into the framework. That actually does exist in Wolverine, but what Wolverine does is it takes your class, your method, and it generates on the fly, generates C# code, compiles to be its own adapter internally. When it does that, it's actually going to bake in the call to the validator here. So this method here, let's show it again. And another thing I want you to see, everything's static. We don't have to create anything. I'm using method injection to just push in the items DB context as necessary and building all this up. Same time, I want to create a new item. I want to add it to the DB context. There's a little bit of transactional middleware I've put around this. So it's going to handle calling DB context, save changes. And at the same time, I want to raise an event message for who knows what to go handle this. Tell me what it's doing and just get it off asynchronously. Wolverine's be able to wrap this with its own code. We're being able to use, a nice static method. We're being able to do this with something, not have to worry about asynchronous stuff, not have to do a whole lot of anything. So this is the simplest possible example. To your question about magic, no promises here. I haven't tried this, and everybody should know how it goes when you try to do unplanned demos. Let me just make sure everything's set up. I know it doesn't look good, but there's a bunch of warnings. What I'm going to do is I'm going to pre-generate the code just so we can see the goop that Wolverine puts around things. We're just being a little slow here. Let's try this. Hopefully it goes a lot faster. Cool. So same code we were looking at, your question of what can you do with Wolverine to unravel the magic? This. You can preview the code that Wolverine is generating around it. You can even use this pre-generated. So this is showing you how it's building the items DB context. I don't actually have the Fluent validation middleware on. If it was, you would see that showing up here. You can see where we're calling this. We're gathering this up to publish the outgoing message, that kind of cascaded message. We're saving the transaction, and if the transaction works, we're committing the transaction. It's maybe not clear, but what that is also doing is it is releasing the messages we kind of queued up to send out, so they go out as the outbox. So the messages that you actually enqueued never go out until the transaction succeeds. This one's pretty simple, but more complicated things we get into later. Let's kind of pre-generate the code, show me what you're doing, You see, we tried really hard to even try to put in more comments in the generated code to try to explain what's it doing here? Why is it doing this kind of stuff? And you can even see some logging stuff it does in here too. The line I've got highlighted, just kind of curiosity, this is adding a tag to OpenTelemetry, just telling you, hey, this is the message handler I'm executing right here. So you have a little more contextual information on the OTel activity. And if you care, Wolverine's putting a lot more stuff around it too. What's the tenant ID, correlation stuff, just all the stuff you would expect. Okay. Let me look at my notes, and I'm supposed to show a little bit more complicated one next. Okay, now let's add Martin into the picture here. This case, we're going to be using event sourcing for persistence in this example. Okay, I've got a handler version of this. So we're developers. We live our lives being kind of managed by Jira, GitHub issues, whatnot. Let's pretend we're building a incident tracking system. We're going to use Martin for event sourcing. Our key concept here is an incident. So one command that is categorize incident. Show you the command, a little bit of stuff, and it does have a validator in here. We're coming down here. Depending upon the state of the current incident, we're going to send 0 to 1 events appended to the stream. We might send 0 to many outgoing messages at the same time. These are little Wolverine helpers. Just try to Wolverine what I'm going in here. On our command, categorize incident, this ID property, yes, there's a little bit of magic. It is assumed to be the stream ID, the incident ID. The pre-generated code is going to unwind that for us. Setting up, this is called the aggregate handler workflow with Wolverine. Pretty documented, lots of examples. We did a previous live stream on this. But our single vertical slice here, we're taking in the command. From the command, Wolverine knows I can go look up this incident. I'm going to look it up through Martin. This is going to set us up for optimistic concurrency protection. It is actually setting us up. I'll show this as an endpoint in just a second. It will actually stop the command if there is not an incident matching the command here. That's kind of done for you, so you don't have to check it yourself coming in. But declaratively, now we've got a pure function. Here's a command. Here's the existing state of the incident. You tell me what you should do. So our unit test, this little pure function, push data into it, and unit test the behavior coming back out. Did you decide to append an event and just test this logic, test the shape of it? And did you decide to send a message out? And you can check, did it formulate the message right? Did it send the right messages? Kind of imagine too, if this is a more complicated business operation. I was working with a client yesterday who had just got done refactoring, more typical mediator-ish approach for an operation to a Wolverine pure function. And in this case, there was a lot of left-hand, right-hand code and a lot of business logic deciding, a lot of date logic. What happened, where they got to was now their message handler code, they could test a lot of the business logic and how it was deciding how to divide up business periods, and just write more effective unit tests without dealing with mocks or databases or whatnot, or IOC containers. Okay. Let me check for questions while that comes up. Let's check out the HP endpoints. So Wolverine, it's not just an asynchronous messaging tool. It can typically be used as a mediator tool. That's not what it was meant for, but that's still valuable sometimes. And there's also a Wolverine HTTP package that's an alternative ASP.NET Core endpoint model. And just so everybody knows, Wolverine HTTP can be used at the same time, mix and match, same application with MVC Core, minimal API. You could even throw in fast endpoints or tools like Identity Server that have their own custom endpoint model. Not sure you want to mix and match that, but you could. Let's look at doing this through an HTTP endpoint. The only thing that's usually different is kind of the same thing here. Let's say that I'm going to specify a URL. So I need to throw in Wolverine post, Wolverine get, Wolverine whatever HTTP method. I can also work with ASP.NET Core services. I could take in HTTP context, a lot of other things. You can bypass the magic and get straight down to the low level metal if you need it. For right now, let's look at this. This is the same equivalent. Dog's getting fussy. A little bit of extra stuff. Let's pretend we've got a little bit of middleware here that looks up the user based on the claims principle, looks up the database, grabs the user, gives it to us all in one spot. We're still got a pure function. We're pushing in. What's a little bit different, we're going to get to this. We're going to go back over the sample again for railway programming. Especially on the HTTP side, I can say, hey, if we don't find the incident, it's going to require, we can have it kind of abort the request and do something else. The default is 404, no matter how this is coming. We could say problem, blah, blah, blah. And we could even add a little bit of logic to get the right message. So this case, if you post the categorized incident body and it refers to an incident that doesn't actually exist in the database, without you writing any code, this will stop the request. It'll return problems details, body with a node of Y and a status code of 400. All pretty declarative. We're going to get to the point, same kind of thing here, exact same logic here. And we get to Motor Railway. I'm also going to throw in some extra validations ahead of it. We're going to look at the incident. Let's say we have a business rule that we're not going to allow you to categorize an incident that's already closed. I'm making up stuff. So this is kind of a guard clause that's going to run first. And if the incident that we're already loading, same one we're referring to here, if it's closed, we're going to stop. We're going to return a problem details to the response, tell you why. But if it's not closed, it's all good. Just keep going. Any questions on that while I get the next example set up? Now, I don't know about everybody else. Our family dog will be quiet all day until I start talking to the screen on a Zoom call. Then he'll just go nuts. All right, let me check questions. Okay, question. The right attribute in logic and incident handler. Does the handler part of infrastructure service? Because it's in a domain layer, it's kind of thing that usually should be avoided. I don't care. But that's a good conversation to have here. We're almost purposely eliminating the concept of layering, the layering in the clean and onion architecture, where it might be separate folders, separate namespaces, separate projects. We absolutely, let me go back to where it was. We 100% care about decoupling the business logic from infrastructure. The business logic we should be able to reason about it independently of the infrastructure. We should be able to test it completely independently, which we can do. I mean, yeah, there's an attribute here, but you kind of ignore it. You can still write unit tests directly against this. I think the value judgment here, especially with this vertical slice stuff, when we get to more complicated data access, having I'll show examples. We'll actually put the data access directly in the endpoints or message handlers, especially if they're not shared between slices. I'm going to say that to me, it is more valuable to keep that very closely related code together, where you can see maybe even in steps of I do this, then I do that, then I do the main handler, and this other stuff happens. Being able to reason about the cause and effect, and especially being able to understand why is this application so slow when I call this web service? Well, okay, here's the exact data access queries that are happening right here. I can see that. So yes, this absolutely 100% violates clean architecture. It might violate some DDD type rules. I hate that stuff anyway. And I'm claiming there's more value in doing this and shrinking the code way down than there is creating the extra layerings and to enforce separation. You are absolutely okay in disagreeing with me, though, folks. There's room in the world for all of us. We'll look at one more endpoint here. Let's get down to the simplest possible thing. This is a little bit of preview of some of the things we're going to do in a little bit. This is actually using EF Core behind the scenes. This is a kind of a version of something we already saw. So new method. I want to take in a create item command from HP, and I'm potentially going to raise a message. Hey, an item created, event message for who knows what to do stuff with it. And I want to go insert a new one. So this is part of Wolverine's declarative data access. It's mostly useful for simple things. But there's a lot of simple things that we do in a system, even in a complicated system. So this is doing the work of declaring, hey, I want to insert this item to the right DB context. It is still wrapping it with the transaction. It's potentially using the transactional outbox correctly, and off we go. Same thing on the get method. Here, identity. I'm using this entity attribute that just says, hey, I want to look up the item. Again, yeah, there's a little magic. All this can be overridden a little more explicitly, but it says, hey, I've got an ID route value. I'm going to use that. I know what the identity type is from item from the DB context and the system. I'm going to go look it up from the DB context, and I'm just going to return it. Same thing over here. I'm not messing with any kind of OK result or any kind of stuff like that. I'm going to write the simplest possible code I can. Wolverine HP is actually going to be able to infer a lot of the open API metadata off of this. It knows that you return an item. And more than that, it can also know that I potentially return a 404. So if this item isn't found, it's going to return a 404 for you. Again, trying to find ways to reduce repetitive ceremony. This came about after kind of looking over the shoulder of some Jasper FX clients, and just, it's really good for me to kind of see, oh, you've got a lot of repetitive code there. Hey, there's something we could do to crush that down. And that's what you see here. Okay, so as always, I have more content than I'm going to be able to get through today. I think I will probably do a part 2 of this if anybody's interested. This is the most important concept for the entire approach of Wolverine handlers, especially in the vertical slice world. You see Jim Shore of extreme programming fame wrote a paper called Testability Without Mocks. Sooner or later, I inevitably recommend it to every single client I've ever had and will ever have. It has a lot of good things to say about creating testability in your system without reverting to abstractions or ports adapter type thinking. One second. So the A-frame idea. If you're coming from an FP world, you probably will find a lot more information about this. they refer to this idea, the idea of imperative shell functional core. But the idea, we're going to keep our true business domain logic or behavior, the code that decides what to do next, we're going to keep that as pure functions. Pure functions that don't have side effects and that are really easy to test, really easy to reason about it. But then there's going to be kind of a goopy layer surrounding it that interacts with all the messy stuff in your system, the databases, the message brokers, external web services, whatever they are, kind of being a go-between. In our A-frame kind of world, let me get back, look at the code we were just looking at. So this is an example of A-frame where Wolverine is kind of on top. Wolverine is kind of being the go-between everything. Wolverine it's calling our domain class. It's taking outputs from the domain class, this domain logic, this insert, and this, and it's relaying this to the right DB context. It's relaying information to the transactional outbox. It's dealing with transaction stuff for us. It's dealing with logging for us. Maybe other things. And then finally, it's also handling, I'm going to push this item created off to the message broker. But our domain logic here is pretty simple. Here's all your information. Do stuff with it. So this is where the A-frame comes on top. Like some kind of controller or mediator, or if you like Rebecca Worth-Brock's old work on responsibility-driven design, I think this would be like her idea of the stereotype of a coordinator or conductor. This is kind of being a go-between. I'm going to talk to the infrastructure. I'm going to get stuff. I'm going to push it to the domain logic, which can be pure and nice and clean and just do its stuff, get it out, and put it back into the infrastructure. This is how, back to the concern of, hey, technically there are some infrastructure-y type attributes in here. And yes, try really hard to minimize the usage of attributes, but sometimes it's the thing. Yes, it's in here, but this is still a pure function. Pure function, it's not talking to other services. It's just here, it is given all the data it needs, and it is returning back out what should happen next. What events should be appended to the current stream? What other outgoing messages should be pumped through the message broker? What's really different here, I think this is compare this and contrast this to the ports and adapter style thinking of any of the clean onion hexagonal architectures we're all seeing today. Those approaches usually end up relying on abstractions, where the domain layer, the application layer, is using abstractions around the infrastructure. In this case, we're not going to do that. We're going to create that decoupling through this intermediary kind of conducting layer. With Wolverine doing this for you and generating a lot of code around you, that's what's enabling you to write these pure functions and know that Wolverine is going to deal with the stuff around it. All right. While I'm looking up, feel free to type in any questions while I get the next example set. So cascading messages and side effects. I want to start with side effects because that's a little simpler. We talked a lot about using the actual message handlers or the endpoint, the main method, as the behavior that decides what to do next. In the event sourcing example, that's actually called the decider pattern, but same thing here. Let me show a super example, and we're going to talk about Wolverine side effects. Again, this is something that came from people that were interested in using functional programming approaches. All right, so real common thing. When you're building a system, you may be getting business, some kind of command from the outside world. Maybe it's a file, who knows what it is. maybe there's a little bit of logic, and at some point you decide to do it or not do it, and maybe you need to write a bunch of data to an S3 bucket or Azure Blob Storage, or write it to a file. But you still want to keep your business logic of deciding what to do and what to write. You want that to be pure and testable. So to that end, Wolverine has this formal idea of a side effect. If we have real FP people, I think this is an example of a monad, or at least it's analogous to a monad. But I'm not going to lie and say that I know that for sure. So real FP people can write in. But let's say we have a real simple one. It's just a marker interface. Wolverine is going to be looking for either an execute or an execute async method, and it's going to know how to deal with it from there. This can still take in IOC registered services. I won't get into this too much. But write file, by using this, is just telling us, hey, I want to write this file. Let's see it in usage. So ridiculously simple example from the documentation. Here's our command. Here's our command handler. By returning this as part of the return signature, Wolverine's going to see, oh, this is a side effect. This means this is something that I'm going to execute in the course of the full message handler. It's going to happen in line. It's going to be part of the current transaction, whatever it is, just off the side. So this method can be pure. Here. Make it static even. This can be pure. We can test. Are we putting in the right content here? Are we giving it the right file name? We can still unit test this, but the real thing will actually execute it and write the file. So pure FP stuff, pure functions, kind of isolating the side effects so you can still unit test things. And it means we don't have any abstractions we got to worry about. Let me look at something that's a little bit more. No, let's do something that's doing a database. So back to our incident tracking system. This time we got an HTTP endpoint where we want to log a brand new incident. I'll keep this pretty simple. Look at our response here. It's returning creation response that's very analogous to results.created. It just helps generate a little bit of open API metadata. But the other thing, the start stream, this is a side effect. It's going to have a little bit of information where we are just going to say, hey, I want a new event stream created. It's this aggregate type. Here are the events I want to pin to it to start with, and some identity to it. But when Wolverine sees this and it's wrapping its own code around this, it knows that, hey, I'm going to invoke something against Martin, and then I need a Martin transaction around that. And I'm going to set up transactional outbox stuff around that if we were doing any messaging as well. Key point here, this iStart stream is going to be executed right after this post is called. Post, Wolverine's going to execute this against the Martin document session, save it, and then finally write out the response, assuming that everything's actually successful. So one last time, this happens in line. But doing it this way enables us to be pretty declarative. If it comes out as a null, then if it's null, Wolverine doesn't do anything. I mean, you may decide not to do anything. But by returning this as a pure function, this will allow us to do a unit test where we can examine the iStart stream coming out, and we can check, did it try to append the exact same, the correct events that we expected it to do. This also could come out as something that just says do nothing. The point here, there's probably a lot more to look at in the documentation. This isn't comprehensive. Point still pure function. This gives us a way to unit test all the stuff on the backside without ever doing any mock objects, without ever putting any database stuff in, without running any message brokers. Let me take a quick question, and then I'm going to do a couple more examples. So do I still need to create DD style services or just stick with handlers and domain objects? That's always, it depends. If your handler is getting too big, then look for ways to pull stuff out. I think one of the advantages of vertical slice architecture probably doesn't get enough attention is if you're saying that one handler is one message type for the most part, it's pretty clean to start pulling little helper methods out. Just doing extract method, like we're doing old fashioned, just good procedural coding from years ago. I used the term with a client the other day, the composed method idea from about 15, 20 years ago, of just how to compose helper methods so you don't have giant methods and giant arrowhead code. I think that goes a long ways. I think for the most part, the average feature you can pull this off such that you can do every single thing in an endpoint or handler. Just remembering that you can actually divide things up in Wolverine, or you can pull out private, sub helper methods all you want. If you find a lot of application logic being reused across endpoints or whatnot, then yeah, I would pull that out too. I would pull that at helpers. And you can you can absolutely use any kind of IOC services as well in these endpoints or handlers. I don't think we're going to get to it in this first section. I think this is going to be a two-parter cliffhanger. Just like we used to hate when we were kids. When I'm old enough that you get to the end of a Dukes of Hazzard episode and they're jumping the car, and you get to be continued next week. We'll talk about data access, and I think something that's pretty important is if it's functionality that is only belonging to this one slice, I would try to put it right in the handler or the endpoint. We'll also talk a little bit about Martin has some capabilities to do the specification pattern built in. It's probably not, I know I don't talk about it enough, so I want to bring that up as another way to reuse things. And that would be done without having to inject IOC services and all that kind of junk. Hope that answers some of that. Okay. Now I want to talk about cascading messages. And all this really means, we've already looked at this. Let's see. Here's yet another example of this kind of aggregate handler workflow, the CritterStack's version of the decider pattern from event sourcing. So in this case, we have a command to close the incident. And one thing we'll do is if the incident is already closed, do absolutely nothing. This outgoing messages, it's just a list of objects that has special meaning to Wolverine. It just means anything that's in this list is meant to be sent out as a message. Instead of pushing in instead of injecting the Wolverine iMessage bus and using asynchronous publish async like this, which is valid, instead we'll keep to this idea of a pure function. This return here, this is just publishing an archive incident message, and I'm using the Wolverine scheduled message functionality here. I just return this out of the method. Benefit of that is always, this is all about unit testing, being able to keep async junk away from your main handlers or HP methods as much as possible. Just trying to make code a little bit cleaner. It's exactly the equivalent of calling await bus.publish async. It's just make our unit testing cleaner. Let me look at another example. This time we're actually going to go into a Saga. Let me show everything now. Yeah. So sagas in Wolverine with both either Martin or EF Core becomes very, very clean. So this is starting a new order. I'm sure it would do more, but we're going to return an order itself. Starting from the start order command, we're going to return the order itself. That's the saga. That's initiating the saga. That's a special thing. But this cascading thing too, we're going to also return, I want an order timeout. I'm going to publish a message that is going to be, I don't know why it's going to do this, but like a minute from now, this is going to be executed. And if the saga hasn't already been completed in that time, we're just going to wipe it away. It's test code. But by using cascading messages in your signature, you can start to see a cause and effect much more cleanly, I think, between here's the command, here's the message that it continues with. I think this is a great way, especially to take a really, really long running process and divide it into steps, or maybe all you do is I return, cascade out a message that does step 2, 3, 4, whatever it's going to be. So with that one, I actually have a lot more content. If everybody can be okay with this, I'm going to schedule a live stream for early next week to do the second half of this. And I'll publish that as part 2. So on that note, probably just want to see if there are any questions before I shut this down. And also, I do want to say thank you everybody coming. This has been the best attended of all the live streams. Not that that's saying much. Let me run through some of the questions. The advice from the docs that an event handler should only have a single handler method. Any code generation concerns? Actually, yes. So next time we'll talk about Wolverine support for railway programming. There's some naming conventions on methods that are called, and you saw a little bit of this before, validate, load. If you're going to do anything that's complicated, a compound handler, then you absolutely want to do one message type per handler. If it's a bunch of really small things and their commands or events that are really closely related and it's all simplistic, sure, throw them together in one class. That's kind of nice too. When I was doing the saga here at the end, sagas especially, because it's really a state machine of, here's an input, okay, and I'm going to decide what to do next, and this other stuff is going to kind of scatter around, go do other actions and come back. A saga, that really is a special message handler where they're all self-contained. It depends. I think it's by feel. If you're doing anything complicated whatsoever, then definitely one message type per handler or endpoint. And then also we'll get into the file organization. I kind of like having, if they're complicated in the slightest, I like naming the file after the command or the query object itself and sticking everything else in that file, that screaming architecture idea. Message map. Once you reach out in Discord, I'm not 100% sure what you mean, and I'm kind of out of juice. So, anything else at the last second? Oh, Mongo. Not very many people have asked about Mongo. Because Postgres is Martin's on Postgres. That's naturally where we've gone to. Postgres just seems to be kind of winning out as the main, not the main database, but it's the most commonly used database, even in the .NET world. So, we don't even get as many people nitpicking us about not supporting SQL Server anymore. Well, we do, but not for event sourcing. Hey, folks, on that, thank you so much for hanging around. I will schedule the part 2 of this sometime in the middle of next week. Might move it to a more European friendly time, but it'll be still good. On that one, everybody, happy Thursday. I'll talk to you soon.